So I created the original BristleBot by following the exact instructions. So you can see here's my BristleBot at the end. And you'll notice, as my videos, I observed some erratic movement. The BristleBot mostly moved in circles on the floor. So I thought about it and considered ways to make this a more STEM-worthy activity. The original BristleBot kind of felt more like an art project rather than an educational one. So I recognized the need for a structured approach or just a problem to solve to improve the learning potential of this BristleBot. So in my redesign, I decided that the problem I wanted to identify was to engineer legs for the BristleBot so that I could move in a straight line. All right, so now that I know I had to modify the legs for better straight line movement, I started sourcing materials from around the house and kind of focused on items that could be used in a classroom setting. So I came up with the pile that you see in front of you on the screen. And I kind of just began to sketch out some ideas. I looked at how much the original bot weighed, the length of its legs, which kind of felt too short to help control movement. And then I got to designing. All right, so here's my first redesign attempt. I developed new legs using a flexible plastic straw you could see draped over it, along with paper legs. And it resulted in movement, as you could see, that was still circular, but I definitely observed differences in the stability of the bot. I was paying close attention to kind of the mass and the length of legs, seeing if those variables would affect the movement. So I went back to the drawing board and decided kind of how to make it better. I focused kind of on maybe having a little bit less friction, shorter legs, and having it hover on the bristles more. So I experimented with paper legs, as you can see, maintained the mass, but modified the structure just to see if more contact with the bristles would be helpful. And you'll see how it reacted. Again, a circular motion. So back to the drawing board again. So next I tried different leg designs, and I was trying to increase the ground contact and stability of the bot. So basically I added Lego pieces to the ends of the straws. You'll notice it changed the mass slightly and each leg length. And there was some notable improvements in the straight line movement, as you'll see next. Notice it's moving pretty straight compared to what I had built in my other two prototypes. So the previous build kind of got me thinking about an airplane type model. So my final redesign, I developed the legs to kind of almost resemble an airplane. I used a lollipop stick, little furniture pads, and Play-Doh you'll notice on the ends of the pads for try to distribute the weight differently. And then these paper vertical straws were helping so that the wings couldn't really go too high or too low. I achieved a weight of 0.35 ounces and the legs were about 10 centimeters each. So significantly longer than the previous prototypes. And you'll notice the motion here. There it is. My cat did not seem intrigued, but I felt as though it was the most straight line movement for all the prototypes that I created. So I was pretty content with the last one that I created. So my daughter got home from school. She became pretty engaged in what I was doing, and she started to kind of experiment with the weight distribution using small little clips and attaching one to each side, letting it go, bringing it back, and trying to get it to follow the straightest line possible. So if I just given her the bot itself, I don't think she would have played with it as long, but she kind of had something that she was trying to solve and work at. So it went pretty well. So I compared the two lessons using the STEM lesson specification checklist. And in regards to the BristleBot kit, I found many gaps. Other than following directions, there really wasn't an engineering challenge. They did not take part in the design process, problem solving, or really any mathematical or science applications. While re-engineering the bot, I think there was a clear engineering challenge for students and for myself. It emphasized the importance of testing, collecting data, evaluating our solutions, learning from our mistakes and trying again, as well as communicating our designs to others. Lastly, I took a look at the STEM practices, and overall the BristleBot kit provides a foundation, but it needs more focus on engineering principles. I only really found two practices that the kit fulfilled. If I were to create a lesson geared at students, or myself in this case, to alter the legs for straightforward motion, I think the students and myself are encouraged to engage in problem solving and experimentation. If set up appropriately, I think we or the students would be working in teams. They're collecting data, they're analyzing results, they're rebuilding, they're attending to measurements and precision. I think overall, they're engineering a bot with a purpose rather than just for play. Thanks for listening.